All right, so section 3.3, number 92. We're given this fifth order quadratic polynomial, and we are told to find all the real zeros of this polynomial function. Okay, I'm going to give you one better. I'm going to find all the zeros and write this thing in an entirely factored form if I can. If I look at the graph, it's going to end up with three real zeros, right? One at -2, one at 0, and one at 1. Okay? X equals 0, which means that x is a factor. X is equal to -2, which means x plus 2 is a factor. And x is equal to 1, which means x minus 1 is a factor. Okay? Now this thing has up to 5 zeros. Some of them can be repeated. The graph looks like it only has 3. But what this means is that I can divide these 3 out. 3 linear factors out of a fifth order polynomial leaves me with a quadratic, an x squared term that I can use a quadratic equation on. From there, I can see whether or not I have either repeated zeros or if I have 2 imaginary zeros. Because if I only have 3, either one of these is repeated as multiplicity 3, 2 of them have multiplicity 2, or the other 2 zeros are imaginary, right? They don't cross the x-axis. They're not real zeros. They're imaginary zeros. Anyway, let's divide these things out. Okay, the first one is easy, right? It's the x. There is an x in every single term here. So I can rewrite this quadratic by pulling just an x out. Well, that's an easy one. X times x to the 4th minus x cubed minus 3x squared plus 5x minus 2. Okay? Now, what that means is that these other 2 zeros, well, they have to be in here. Let's do the x plus 2 one first, right? Let's divide this quartic by x plus 2 and see what we get. Okay. X plus 2, dividing out this quartic, x to the 4th minus x cubed minus 3x squared plus 5x minus 2. Excuse me. What do I need to do to x to make it look like the leading term? X cubed will make the x look like x to the 4th. X cubed times 2 is minus 2x cubed. We subtract, which means that it's the same thing as flipping the signs and adding. Whoa, what happened? Plus, plus. Minus signs. Don't let them fool you. Right? Now we flip the signs and add. X to the 4th minus x to the 4th is 0. X cubed minus 2x cubed is minus 3x cubed. Minus 3x squared is the next piece we need. Let's pull that down. What do I need to do to x to make it look like minus 3x cubed? Well, I need to multiply by a -3, and I need to multiply by an x squared. I need 2 more x's here. Minus 3x squared times x is a minus 3x cubed. Minus 3x squared times a positive 2 is a minus 6x squared. Okay, now we are subtracting, which means that it's the same thing as flipping the signs and adding. This piece cancels. This becomes a positive 3x squared. And then I bring down my 5x. 5x. Getting loopy, right? What do I need to do to the x to make it like 3x squared? I multiply by 3x. 3x times x is a 3x squared. 3x times 2 is a 6x squared. 6x, right? There's no x here, there's 1x there. I subtract, which is the same thing as flipping the signs and adding. This cancels. 5 minus 6 is a minus x. I bring down the -2, What do I need to do to x to make it look like a negative x is multiply by a negative 1. This becomes a negative x. This becomes a minus 2. And then I subtract this, which is the same as flipping the signs and adding. And I have a remainder of 0. What that means is that I picked this thing beautifully, right? I picked it so that when I got the graph, I saw it crossing at negative 2. I picked the right factor of x plus 2. I have no remainder, which is kind of off the screen, but it's there. Okay. So, we can write this now as x times x plus 2 times this cubic. X cubed minus 3x squared plus 3x minus 1. Okay? These statements, this one, and this one, are all the same thing. All right? Now I want to look at my other 0 that it looks like is the other 0 here. It's x equal 1. But it's not going to be the 0 here, it's not going to be the 0 here, but it might be a 0 here. Right? It might be a factor of this thing. So let's divide out and see what we get. X minus 1 is dividing our x cubed minus 3x squared plus 3x minus 1. All right, same questions over and over and over again. It's starting to get to me a little bit here, right? I'll multiply x squared by x to get an x cubed, multiply x squared by negative 1 to get a negative x squared. We subtract, which is the same thing as flipping the signs and adding. Right? X cubed minus x cubed goes away. 3x squared plus x squared is a minus 2x squared. Then we bring down our 3x. What do I need to do to x to make it look like a minus 2x squared? I multiply that by minus 2x. Minus 2x times x is a minus 2x squared. Minus 2x times a minus 1 is a positive 2x. And then I subtract. Subtraction is the same thing as flipping the signs and adding. Minus 2x squared and a 2x squared cancel. Good, we constructed it right. 3x minus 2x is an x. What do I need to do to the x to make it look like x? Well, multiply by 1, right? A 1 is the only thing that we're going to need here, right? And 1 times x is x, 1 times negative 1 is negative 1. We subtract, which is the same thing as flipping the signs and adding. 0, 0. Right? We have no remainder, which means that x minus 1 is also a factor here. Okay? So, we can rewrite this as x, which we haven't done anything with, times x plus 2, which we haven't done anything with, times x minus 1 times this quadratic. Okay? All right. So, again, now we have 4 statements here. 1, 2, 3, 4 of the same thing. At each step, we've pulled out a linear factor, gotten a polynomial that is 1 degree less. Right? Now we have 2 factors, so our remaining polynomial is 2 degrees less than we started with. We've pulled out 3 factors, so our remaining polynomial is 3 degrees less than we started with. Okay? Now this piece, this last piece. We know that there aren't any different zeros by looking at the graph, right? The only ones that we saw were at 0, negative 2, and 1. So what that means is that this thing either can have no real zeros, or the only ones it can have are ones we already have. Okay? I look at this thing, I can see that I can factor this. This is a square, right? This is x minus 1 squared. So this piece I can write as x minus 1 times x minus 1. X times x is x squared. x times minus 1 is a minus x, x times minus 1 is a minus x, so we have 2 minus x's, minus 1 times minus 1 is a 1. So this thing fully factors out, right? So that's this. This is still multiplying because I haven't done anything with that. This is still multiplying because I haven't done anything with that. And this is still multiplying because I haven't done anything with that. All right, so these are zeros. We have the 0 at 0 has a multiplicity 1, right? There's only one of these guys. X plus 2, the one at negative 2, has multiplicity 1 because there's only one of these guys. At 1, it has a multiplicity of 1, 2, 3. So the 0 at 1 has a multiplicity of 3 because it appears as a factor 3 times. We're done. Huzzah! Get some sleep.